So randomization is hugely important because if I wanted to make a case that drivers in New York are terrible, it really would kind of matter where I was when I was collecting that data. So we use randomization to decide on things like time of day or location on a map, any number of possibilities. We let the calculator or computer decide for us where we're going to collect the data. This way we're taking out any perception, because I'll tell you right now, if I was collecting my data showing that drivers in New York are terrible, all I have to do is stand up, probably on the platform at White Plains train station, and look out at the street. And I'll have all the data I want to justify that. But it wouldn't be fair. It wouldn't be accurate data to represent the entirety of New York State. Right? Because there are some wonderful drivers out there. They just don't live around here. And so we would need to collect that information using some unbiased approach. This is the beginnings of that. So we start with dice, and then we eventually graduate to the more complicated but more interesting situation. So we're going to simulate 7 rolls of a fair die, and then find the probability of getting a 4. I did have a student who was so against the graphing calculator that the question was, could I bring a die to the test and use that in order to figure out some of these things? Like, they wanted to randomly actually simulate I think it was like 50 rolls of a die or something like that, by actually rolling it during a test. And so I actually happened to have dice on me that day. And so it wasn't during a test. I was like, all right, let me just play this out real quick. I rolled the die once off the desktop. Most of the class is like, yeah, no, you're not doing that during a test. 50 times, like all that noise, they're like, I'm going to fail the test just because you're rolling a die. Forget you. Learn how to use a calculator. So for 7 rolls of a die, you don't need technology. 300, you do. Anything more than 1,000, you're not even using a graphing calculator, you're using a computer random number generator. Excel has it built in, Google Sheets has it built in. I'll show you how to use that before it's all said and done. And fun fact, so does GeoGebra. I mean, it's still, I don't want to say it's in its infancy, but it's still in the early stages. It will get better as time goes on, and even some of the instructions when I first typed up that first tech assignment, some of those instructions changed just from last semester because the platform changed. So it will get better and better, just unfortunately maybe not in time for you to make use of it, but we'll see. So math, probability, random integer, right? So in our calculator, so I'm going to clear out my home screen. I'm going to go to math, the math key. Then in the top, all these titles, they represent different columns. Numbers, complex. Some of the other older 84s and 83s don't have all of these options, but you do have the probability one. So the right arrow to the probability, and then it would be option 2. Option 2, jeez. It's not even option 3. These are just the steps. I can't even get out of my own way here. It's option 5. All right, so let me make a note of that. Math, probability, option 5. I'm probably due for a rephrasing on this also, so I'll take that as a typo. Rephrase the first 2 examples on page 30. And that's because more and more people have the newer TI-84s, so your interface won't look like this. It'll look like this. So the lower number in my set, I'm talking about rolling a die. The lowest number you can get is a 1. The upper bound, the largest number you can get is a 6. And n represents the number of trials. So in this case, 7 rolls of a fair die. Right? N is always the number of times that you're doing something. Right. Yeah, I'm going to show both ways. Because, because of like instructional excellence. Anyway, so paste, and then this comes up, and you could just hit enter if you have this kind of calculator and you get this display. All right, I'll switch over to the TI-84 regular in a second. Folks, just so you know, I'm working with, I believe, 4 different varieties of TI calculators in this class. So odds are, when I go over something, it's probably not going to be the way your calculator is working, but it's the way somebody's calculator is working. So I have to go through the different ways, at least until the point where people actually listen in the beginning of the semester and get to want to tell you. But so this is a set of outcomes. Now, it's random integers, random. So if you had the same kind of calculator and did exactly what I just did, and you came up with a different set of numbers, that's a good thing. It's supposed to be random. If you came up with the exact same set of numbers, what that means is that you've used the random integer function exactly the same number of times that I have. Because the calculators are all built with a random seed programmed in, which is a starting point for the program that generates the random numbers. So if we were to start off with brand new calculators, run this approach, the first time we get the same outcomes. The second time, now it starts to vary. All right. So any array of 7 values is going to be good. All right. So that's the TI-84 plus CE Mega color screen fancy one. So let's take a look at just the TI-84 plus, which apparently was used to do stuff in this class.
Put it in the calculator manual, but if we put 1, then comma 7, comma 6.
6, comma 7.
I know, but if you do it the other way, they're gonna screw up the whole equation.
Yeah, because it'll give you the numbers 1 through 7 6 times. All right, so math, probability, option 5. So some of our calculators have this display, in which case the instructions actually kind of work. So 1, comma 6, comma 7. That store into L1 business, you could do it or not. It's only 7 values, so you probably don't need it. So I'll wait until the next problem to actually do that. So for now, we'll just close it up and hit enter. So I have used on my 2 calculators that are built in here the random integer function for the first time since it was reset. So that's why they gave the same outcomes, but that's not always going to be the case. Okay. So I can get this and pop it in.
Yeah, I think that number is the negative.
Okay. Yeah, so that's a good thing. So in either calculator, we get the same results, but they could be different results. It doesn't matter. All right. What I want is to just count up the number of times. So I'll just work off of one of them so I'm not looking 2 different places. Count up the number of 4s and divide by 7. So it looks like I only have 1 4 out of 7. So this is my answer. So experimentally, I just determined that the probability of getting a 4 when I roll a die is somewhere in the neighborhood of 1 over 7. It's a small sample, so I can't say definitively that it's 1 over 7, but it's got to be somewhere in that neck of the woods, right? 0 out of 7. If that could happen. Exactly. You're right. The more you introduce additional trials, so in the next one we go up to 300, the closer you're going to get to the true value.
That's what I was going to say. Like, say you get 5 4s out of this. Would you put something like 5 over 7 and, with the law of large numbers, this should
Converge onto something, yeah. Exactly.
So would you like add that as the answer? It did come out like 5 out of 7, but law of large numbers predicts that it would be much lower than this?
I would say yes, because that's pretty much how the question would be phrased. Where I would say, run an experiment using your calculator to determine what the probability of getting a 4 would be. So then maybe you, on your own, try for like 7 trials, then maybe you try 30 trials, then you try 50 trials, and you say, okay, it seems so. This is an example that shows that I know what I'm doing. And as I increase the number of trials, I got closer and
So you
closer to
expect to get closer to the number you're looking for.
exactamundo.
All right, thanks.
No problem. So then it begs the question, and it's a good question. I had 7 outcomes here. They showed up nicely on my screen. What if I have 300 values? I don't want to, first off, I don't want this kind of display. It's going to be a mess. And also, I'm probably going to lose count at some point. I know there'll be 300 values, but counting up the instances in which a 4 shows up, it's very easy to go cross-eyed on this and lose track of things. So we want a different approach. This time I'll do it with the old 84 first. So math, probability, option 5, same deal. I'm going to type in all of this stuff here. All right, so 1, comma, 6, comma, 300. That sideways arrow is the store key, which is right above on, STO with the sideways arrow. Let me do this. All right, so that's your store key. So 1 comma 6 comma 300, and I want all that stored into L1, which is second one. All right, you don't close the parentheses. And maybe the newer calculators can handle it, but every time I've tried to close the parentheses, I got an error message. I don't know what the issue is there, but I don't want to do it, so I'm not going to. So I hit enter. And it seems like it just did the exact thing that I did not want it to do. Like, all this stuff, look at that. Oh, now I'm going to lose track. I don't want to do this. I stored it all into L1. So then I would hit stat, edit. So, well, don't follow the instructions on paper just yet. Just follow what I'm doing. Stat, edit, and you'll see that in L1, I have some stuff in L2 there I'll get rid of. But in L1, I have all of those outcomes. All right, so if you did actually have to count them up, it's going to be easier to do it this way. Not because it's just simply stored here and you can scroll. It's a little nicer to be able to scroll in this menu, but based on the following steps. All right, so what I want to do is I want to sort that column. All right, and I want to sort it, use the sort A option. So I'm going to go, let me just quit out of here. I can even clear this if I want. I'm going to hit stat, option 2, which is sort A. Sort A and sort D are 2 different things. I mean, same idea, but 2 different ways of representing it. A for ascending, D for descending, which means if I use sort A, I'm starting low and ending high. If I use sort D, I'm starting high and ending low. Right? I want to sort all the items in L1. Right? So just, whoa, get back here. Close the parentheses or not, it's not going to make a difference. I'll close them this time. It takes a couple of seconds. It's really weird. The algorithm that sorts is actually more complicated than the algorithm that generates the numbers to begin with. So for larger numbers, you'll see that the sorting process sometimes takes longer than actually developing the random numbers themselves. It's kind of interesting. So then stat, edit. After it says done, you go to stat, edit, and now your numbers are in increasing order. Right? So there's a couple of ways that you can handle this. One would be what I wrote here in bold. Find the list numbers that represent the first 4 and the first 5 and subtract them. Take the result and divide by 300. So I'd have to scroll down, and because this is an emulator that doesn't really emulate very well, I can't just hold down the button and let it go for a ride. You can hold down the down arrow and just Wait. Oh, actually, it is working now. Okay. The calculator just wants to disagree with me today, I think. Oh, and then it stops after a while. Yeah. So you could just hold down the arrow. It'll feel a little bit more comfortable than this. This is slow. It's funny, this graphing calculator is backed up by the power of a computer, but it actually runs slower than your handheld. I think it's because these computers are like also from around the time that I bought that MacBook. I had some serious buyer's remorse when I laid the grand out for that. Because it's like, all right, I got my nice MacBook. And then like it felt like the day later they invented touchscreen. I was like, really? This is what's happening now? So my first four happens at the 160 mark. So right, yeah. So randomization is going to lead to some different outcomes for us. Anything in the neighborhood, I guess, is probably going to be okay. And on a test, I mean, some people have tried to like kind of fake it, like make up data. They didn't know how to do this, so they're like, "Oh, well, my first four was the 30-second value, and my second four, or my first five was the 40-second value, and there was 1,000 trials." And I was like, "Yeah, you didn't do it. Like I know the math." Shockingly. So you're basically telling me that there's a 2 in 1,000 chance that you got a 4. No, that's not going to work. All right. So the first 4 happens at the 160th mark. The first 5 happens when we're at the 204th value. So what I just do is I take 204, subtract from it the 160. I'll get 44. There were 300 trials. So 44 over 300 would be my set of outcomes here. All right. And then you could run the numbers. You could say, what's 44 divided by 300? It's going to be somewhere in the neighborhood of 1/6. 1/6 would actually be 50, so it's going to be a little bit low. But it's experimental. We're expecting some variation. Right? This method is kind of hit or miss in terms of whether people understand it, at least in this context. But it's more like you have 20 people. Okay, so you have 15 people, because I don't feel like writing anymore. And you want to find the distance between two values here. So maybe you want to find the distance between the 5th and the 13th value. Right? So what would happen if I just did 13 minus 5, I would get a result of 8. So now if I actually count them, because I know where it's starting and I know where it's stopping, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So the difference between them is 8. That's true. Because that difference is another word for subtraction. But if I'm looking for how many numbers are in that interval, well then just subtracting the 2 is not going to get it done. So what we do is we just add 1 to that, because the subtraction process finds all the distance between the two numbers. So it's basically telling us that how many moves would it take to get from the beginning to the end. 1, 2, 3, 4, 5, 6, 7, 8. All right. But there's always one more than whatever the distance is between the two numbers. So if in this case I said, okay, well, where's my first 4 and where's my last 4? I'm going to fall 1 unit short. So I go to the next category to find all the values that exist between my first 4 and the first 5, which would necessarily be just 1 short of that 5. All right. A more clever way of doing this, because this is more numerical, a really clever way of doing it and I did not come up with this. That's why it's clever, I think. A student said, "All right, we have 6 numbers that are supposed to occur an equal number of times, right? So why not just let the number 1 equal a 4?" It's really kind of weird. It's like, wait, 1 is not equal to 4, but if they're supposed to occur the same number of times anyway, then any outcome is interchangeable with any other outcome. He said, let's do this because, let me just quit out and come back in just so hopefully it goes right back to the top. It does, okay. If I do it this way, then I just got to figure out how many 1s there are. Which is a little bit of an easier ride. I mean, you still got to go 50 values or so in order to get there. Okay, maybe more. Oh, there we are. So my last one is at the 55 mark. So in that, using that approach, I would say that I have 55 out of 300. Okay, so I could get a different outcome just by redefining things. I mean, in the next problem, we're talking about red marbles and white marbles. Those don't have numerical values associated with it. I could let the red marble be whatever I want. I could let the red marble be the number 7. I can let it be the number 0. I can let it be the number 2. It doesn't make a difference. I can let it be whatever I want because there is an associated probability with that. The probabilities don't change. All right. So if that intuitive approach, the clever way, resonates with you, then go for it. Otherwise, do it the other way. All right. 10 marbles are placed in a bag. 9 are white, 1 is red. Using a simulation method, determine the probability of selecting the red marble after 75 trials with replacement. Right? With replacement allows for independent events, which means that the probabilities aren't going to change from trial to trial. Right? Because if I didn't have replacement, that would mean that when I select a marble, it does not go back in the bag before I select another one. In which case, I couldn't have 75 trials. I'd only have 10 trials because once I selected the last marble, it's all over. All right? So they all have to be going back in. But in this case, we have to develop the experiment first before plugging it into the calculator. So we have 9 white marbles and 1 red marble. So it's a total of 10 marbles. So I'll do a random integer going from 1 to 10. Or 0 to 9 if you want. I'll store that in L1, but what is it, 75 trials? 75 trials, then store it into L anything. L1 is the one I typically go with. All right. So I have 10 marbles. Depending on which marble is selected, I could have the outcome that I'm looking for. All right. But what I want to do is define this. We have 10 numbers to work with. We have a 1. And then we have the 2 through 10. All right. These would be the white marbles. And this is obviously the red because I drew it in red. Let the number 1 be the red marble. Everything else would be white marbles. You can let the 10 be the red marble, and everything else be the white marbles. You could let, like, red could be the number 4. All right, but that doesn't serve a meaningful purpose because then it puts us back in a situation here. If you have a singleton value, let it be either the smallest number in the set or the largest, because when we sort the information out, it's going to be easier to pick out the total if it's one of the lowest, if it's the lowest value or the highest value. All right, so the random integer, when we store it in there, will overwrite everything that's in L1, so you don't have to worry about clearing it. Math, probability, option 5, 1, comma 10, I forgot the 1, 1, comma 10, comma 75, then store into L1. And again, the sorting technique, it's entirely up to you. But I imagine that you probably don't want to scroll through all the data just to say, oh, there's a 1, there's another 1, there's another 1, create a tally chart and figure it out. So sorting is the best way to go. Stat, ascending, lowest to highest, sort all the information in L1. It happened quicker this time, which is kind of nice. And it's definitely nice. It's not kind of nice, it's nice. Other than nicer, it's not. Sometimes people get thrown off with the done. They're like, okay, apparently you're done, but what'd you do? You have to know why you're typing stuff into the calculator. So it's done sorting the information. So now when I go back into my list, I'm looking for how many ones there are. And there it is. All right, so there are a total of 4 ones out of 75 trials. And since we let 1 be the red marble, we're good. So 4 in 75 chance. That's a good question. No, because then you could just make up whatever you want and say, that's what the calculator told me. That's what people sound like in my mind when they say that's what the calculator told me. It's never, that's what the calculator told me. It's more like, that's what the calculator told me. It just always sounds like that. I don't know why. That and what? When people respond, it was like, hey, can we use this basketball court? What? It's always like that. But that actually is not just happening in my mind. That's actually how they sound. I don't know why. But yeah, so what I need from you is what you put into the random integer function, the definition of what the items that are in the interval of values represent. So the 1 through 10, that's wonderful. But what do those numbers 1 through 10 represent? So something along this lines or these lines would work. And then the answer. All right. So it basically boils down to, instead of taking it on faith based on the final answer that you did everything that you should have done, you're providing me with evidence, so it's easier for me to believe that you didn't just make up that final answer. All right. That being said, you could totally just make up the final answer if you have a sense of the situation, because you'd say, okay, I don't know how to actually put this in my calculator, but I know what I'm supposed to type in. It's on my index card. So I write that down. All right, what are we talking about? We're talking about marbles. One's red. There's 10 total. Something in the neighborhood of 1/10 is what I should get, but it's random, so I know enough not to make it exactly 1/10 because he'll know that I made it up. So let's see, 7.5 out of 75 would be 1/10, so something in that neighborhood, so maybe 10 out of 75, right? And actually, in all honesty, if you go through that thought process, I honestly don't, I've lost interest in the calculator, because now I'm interested in, wow, you really get it. That's good stuff. You have a sense of the probabilities. You know how it's supposed to work. Just because you couldn't remember how to type the stuff in doesn't make a difference. You know what you're supposed to do, and you know what it means. That's incredible. Full credit. Because I had 4 ones in my list of outcomes, and I defined 1 as the red marble. Yeah. Which is why there's so much wiggle room in that final answer. It's almost like I don't even really look at it except to make sure it's in the neighborhood of what it should be. So I'm going to put a star next to the last example here, with the expectation that you'll read through it, try to come up with some reasonable scenario, and then if you get that far, try to plug it into your calculator and see what you come up with. But really, it's more so that you are familiar with the question a little bit before I start going over it. Because, I don't know, there's no way to say this without sounding insulting, even though I'm not trying to be. I don't have any kind of real expectation that you would get this correct on the first attempt. And the reason why, it has nothing to do with you. It has to do with the fact that I was watching a Mets broadcast, and Sandy Alderson, who was the GM at the time, was being interviewed. And Gary Cohen, who's the announcer, was having a conversation with him. And he laid this on me Me personally, because he was definitely talking to me. He had to be because I was the only one taking notes on a Mets broadcast. And he was talking about the idea that, and these are real numbers. If you get the leadoff batter on in the game of baseball in an inning, so the first batter gets on base, doesn't matter how, hit, walk, not a home run, I guess, but that would still fall into the category. That team will score one run at least, or at least one run 57% of the time. So more than 50% of the time, so a little bit better than a flip of a coin, you'll get at least one run if you get that leadoff batter on. That's why they always talk about, I mean, if you have any familiarity with baseball, you know what I'm talking about. You want to have the person who has the highest on-base percentage, the person who can get on base most frequently, you want to have them at the top of the order so that they have more at-bats during the game. They're more likely to be a leadoff hitter in an inning. Because they're more likely to be a leadoff hitter and they have a good on-base percentage, they're more likely to get on base. And if they're on base, now, okay, you're on base, now you can flip the coin. Heads or tails, basically maybe a little bit skewed towards heads. But the bottom line is you at least have a respectable chance of getting at least one run. But there's a hidden ingredient there. At least one run could be one run, it could be 30 runs. So how does that break down? That's really not the focus of it. Change it.
Oh yeah, I was just looking at these here. Excuse me. Elite max statistics indication to crush at fantasy football and fantasy baseball.
So you would think, but I have the same record as the New York Giants in my fantasy football league right now.
Really?
No, that's the thing. I used to do that. It was like, all right, I don't know too many of these players. Well, there's a familiar name, there's a familiar name, there's a familiar name. Then I look at my roster and be like, all right, the New York Giants. And I guess we're going to sink and swim with the Giants' performance throughout the season. So I purposely stayed away from Giants and tried to explore some other players that might actually have value that I wouldn't know about. No matter what I come up with, it doesn't work. I am just dreadful at fantasy football. Although
And baseball?
like everything.
Really?
Yeah. Because you know what it is? It's like there is the emotional aspect where it's like, yeah, I know, but in baseball, it's like, all right, I know I should have Chipper Jones, Chase Utley, Jimmy Rollins. Basically, these are all like the worst enemies of the New York Mets. And I know that I should have him on my team, but that guy's a scumbag. That guy, he just beats us all the time. You know, and it's like I just can't do it. And so I think that
They go to the National League.
yeah, just go straight up AL. Yeah, I guess so.
Pitchers from the National League. That's what you do.
Yeah, well, pitchers from the Mets would be fine for the most part. Yeah,
You know, one less batter.
exactly. Yeah, so I mean, there is that stuff, but it just hasn't worked out for me. I don't know, but I did make an inspired move yesterday, and that was I picked up the backup running back for the Cleveland Browns, and Nick Chubb. Yeah. And then the starting running back just got traded to the Jaguars. So I was like, and I had the starting running back for the Browns, Carlos Hyde. I had him, and I was like, you know what, let me pick up Chubb because I heard that he's going to get more carries. They flat out traded that guy to a team where he's going to be more successful now. So I'm going to get those points. And then my backup running back who I took a flyer on just became a starter. People are going to think that I have like some inside knowledge. Like, I don't. I just guessed. It's crazy.